planet have two suns?
For anyone to stand on the surface of a planet and see two setting suns, three things must be true. 1. These close pairs of stars must exist. 2. Planets must be able to form around these double stars. And 3. The planets must be able to stay in orbit around the stars long enough for life to evolve. The first of these questions is easy to answer. These close pairs of stars are everywhere. They're called binary stars, and over half of all the stars that you see in the night sky are really binaries. They're just so far away from us that they look like a single point of light. Some orbit so far apart that from one star, the other just looks like a bright point of light. Others orbit so close to each other that the more massive one pulls the outer atmosphere off the other in a tiny stream of material that swirls down onto the massive star like water spiralling down a plug hole. So, can planets form around binary stars? Well, in fact, some binary stars may be better at forming planets than single stars. Planets form in a process called accretion, from the ring of dust and gas that's left over from the formation of the stars in the system. This ring of stellar junk slowly clumps together into bigger and bigger chunks until they eventually grow to become planets. A second star in the system can have a double benefit. It may increase the clumping of the dust so that even disks with a small amount of material in them can produce planets. And it may also speed the accretion process up, allowing planets to form more quickly than around single stars. There have been a number of Jupiter-sized planets found around binary systems, and a Spitzer Space Telescope study has found planet-forming disks around 40 to 60% of the binary systems they observed. So far it's looking good. The final step is keeping the planets around the binary stars for long enough that life can evolve on the surface. This is the trickiest part of the whole puzzle. In fact, astronomers have found that the vast majority of planetary orbits around binary stars are unstable. At some point in the planet's lifetime, the gravitational tugs of the two stars will cause the planet to either crash into one of the stars or to fly out of the system altogether. The good news is there are some planetary orbits that are stable. The simplest is when two stars are very close together and the planet orbits a long way away from them. Then, even though the stars are moving, the planet wobbles slightly in its orbit, but it remains stable. The second simple scenario is when the stars are a very long way away from each other and the planet only orbits one of them. In this case, both stars may have a planet around them, and two civilizations may evolve as virtual neighbours in the universe. Either way, science fiction's vision of two suns setting in the same sky may be closer to science fact than we on Earth ever thought possible. For Ask an Astronomer, I'm Dr. Carolyn Brinkworth at the Spitzer Science Centre.
What will happen to the Earth when the sun dies?
Our sun is a star, just like every other star in the night sky. Stars are just big, spherical nuclear fusion reactors. The sun is mostly made of hydrogen atoms. When two of these hydrogen atoms smash together inside the sun, they form a helium atom. Only the helium atom weighs a tiny little bit less than the two hydrogen atoms combined. This missing mass has been converted into energy, which shines out into space as sunlight. Our sun has been steadily fusing hydrogen into helium for the last 5 billion years, and astronomers predict that it will continue to do the same thing for another 5 billion years, until it runs out of hydrogen. But what happens then? Does the sun just turn off? The answer is far more exotic. Once the hydrogen runs out, the core of helium at the centre of the sun will start to collapse in on itself. As it does so, it gets hotter and denser until it suddenly starts a second nuclear reaction, turning the helium atoms into carbon and oxygen. At the same time, all of this extra energy from the hotter core pushes out the outer layers of the sun, and the whole thing expands to about 250 times its original size to become a red giant. This is pretty bad news for the Earth. There are basically two possibilities. Either the sun will expand so far that it swallows the Earth whole, in which case it will be destroyed very quickly, or it will expand just enough to leave the Earth intact while roasting everything on its surface to a crisp. The oceans will boil off, the atmosphere will be blown away, and the surface of the Earth may even get hot enough to turn the rock into liquid magma. Whatever the eventual fate of the Earth, there's no way that anything on it will be able to survive. So what about the rest of the planets in our solar system? Mars, Jupiter, Saturn, Uranus and Neptune are far enough away from the Sun they will probably survive the red giant phase, but the Sun hasn't finished just yet. Eventually the helium in the Sun's core will run out, in just the same way the hydrogen did. Once again the Sun's core will collapse, but this time it will never get hot enough to start the next chain of nuclear reactions. The outer layers of the Sun will get puffed off into space as a planetary nebula, and the hot carbon and oxygen core will be left cooling slowly by itself in space. This dying ember is called a white dwarf. Although the white dwarf is very hot, it is also very small, and so the light and heat given out by the star will be much less than it used to be. Any planets that escape the red giant phase will now be caught in a giant freeze as the temperatures plummet well below freezing. Here at the Spitzer Science Centre, we've been looking at many white dwarfs in our galaxy to see if we can spot the remains of ancient planetary systems that used to exist around the stars before they died. Over the last few years, we've discovered dusty disks around many of them, which we think may be the broken up remains of asteroids left over from the death throes of the system. Although they're too small and too cool to see with our telescopes, the Jupiters and Saturns of these ancient solar systems may still be orbiting around their stars billions of years after their sun died. Of course, we don't have to worry about any of this happening during our lifetime. We have about 5 billion years before we have to pack up and leave. But if human beings last longer than the dinosaurs did, then this is something that our direct descendants will eventually see, and the human race will have to look to the stars to find another place to call home. For Ask an Astronomer, I'm Dr. Carolyn Brinkworth at the Spitzer Science Centre.